Good evening. We're going to be talking about how to do a simple t-test. So we first started with the data that we received, which included all grades, all ethnicities. I was able to sort the data by looking at the grade enrolled, the ethnicity, and the campus number as well. And then at that point, I eliminated all of the non-Hispanic fourth graders because the question that I had was whether the raw score mean for the fourth grade Hispanic population on the 2018-19 STAR test was significantly different than the Hispanic population at this one district. And so to do this, I first went to the technical digest at TEA to get the fourth grade reading STAR mean, which was 23.81, and the standard deviation, which was 7.50. The sample for my fourth graders, I used the formula of average to get the mean, which was 22.03, which was 1.78 difference. And the standard deviation, I was able to calculate it using the standard deviation formula. Then with my sample from all of the raw scores for the 18-19 test. So we went through the questions by first asking what test would I use, and so I was going to use this single sample t-test to compare the population mean with the sample mean. The random sample questions, yes, it was because, as previously explained, we didn't choose them. They enrolled at this district. The independence of observations was yes, and the dependent variable was normally distributed. Did that by creating the bin range and then going to the data and creating a histogram. And as you can see, it is normally distributed, and also did a distribution here with by going and inserting the chart to show that the data fell between a quarter here, a quarter there, half in the middle. And when we ran the histogram, we saw the frequency with a few outliers, but primarily distributed a little bit towards the high end. So in listing our hypothesis, we were looking to see, first off, if the population of Hispanics was equal to the district Hispanics, and then that they were not. So we did a two-test non-directional. We set our alpha at 0.05. In calculating our statistics, we looked at our sample, saw there were 519 students that took the test, which gave us a degree of freedom of 5.18. So when we went to the chart to look at our confidence interval, because it was higher than 120, and for a two-tailed test of 0.05 for our alpha, and then we were able to determine 1.96. I did the two-test paired two-sample When I had done the dummy data with only a couple of items, which the previous recording said you only needed two, I kept getting an error message that they needed to be the same. So I duplicated zeros for all 519. And when I did that, then I was able to get a mean of 22.03, which matched up. But I got a t-stat of negative 5.77, and then the p-value of 1.35 for a two-tailed test. Again, the critical value for the two-tailed test was 1.96, which matched up with the chart. So when we put that on the graph, and we thought we would see if we were to fail to reject the null, it would fall between 1.96 and negative 1.96. And what I saw in a t-stat was negative 5.77. So trying to interpret the results, since it fell outside of the parameters, then I needed to reject the null. The average scores, therefore, were higher. And so when I went to do Cohen single sample tests to verify, use the sample mean of 22.03 and our hypothesized population mean of 23.81, the standard deviation. So we got a negative 0.24. So since the size of the effect was less than 0, then that should have had no effect. However, when I calculated the R square, I got a 6.043. And when I did the confidence interval of 95%, it should have fallen between negative 1.33 and negative 2.427. But as you can see here, it's over negative 5.77, which leads me to believe that I will be doing this again with another sample to see what it is that I may have done wrong. But I thought I followed the formulas and it should be true. But it does not appear to fall within the level of confidence that we need.